What is up, everybody? I am Mr. Escobedo, and I will be walking you through our science lab. Today, what we are going to be talking about is how to set up for Newton's second law of motion lab. All right, so I'm going to quickly go over a few things, especially the fact that I'm hoping that you've already heard this once. All right, if not, this is a refresher. All right, so we always look back on what our objective is, right? Students will be able to identify Newton's second law of motion and how it relates to real everyday life situations that we experience. Okay, that should have been the objective this whole week. All right. So in order for me to get started, I hope you guys have a printout of the lab because we're going to be going over it today. If not, in our science folder for today, we will have a printed copy available, or if you're in the class or if you're a roomie, you will be given a copy. All right. So today, students will be going over our lab and what materials that will be needed in order to be successful. So hopefully this is all uploaded on PlayPosit so I can ask you questions. So if I can, hopefully I can give you a question right now. If not, I'm going to keep going. All right, here we go. So the question we ask ourselves when entering this lab specifically is, what factors affect the strength of force exerted on an object? So lots of things comes to this. So the fact that we know that a force is a push or pull, how can we change what we want as a result? So we're going to dive into that right now. So before anything, there is another PowerPoint which shows you and demonstrates the materials that would be needed. But here's the list. If you're at home or you're with me, these are what the things you're going to need. You're going to need a ramp, which is anything you can lean against something. A binder or books, something that can be used to lean the ramp against, and two different objects. The two different objects of different sizes and or weight that will go down your ramp. A toy car, a ball, who knows. All right. A ruler, which hopefully you guys all have, or you can use your planner. But remember, we are using centimeters, but for this experiment, if you don't have one, inches would be okay. A paper cup or a paper ball. Lightweight cup or crumbled up piece of paper in order to show the extraction of the actual force going down. All right. So our hypothesis, which is an educated guess, which I hope you guys all did well in your quiz. So here it is. On your sheet of paper or on your copy of your PDF on your iPad, we see, and you guys get to fill this in, if we increase the mass of an object, then it will require a or an what? Your choices are between a greater or less amount of force to accelerate the object according to Newton's second law. So that's the decision up to you that you guys are going to go through, or whatever is available to you at home. Now, we haven't gone over this, but this is very important. How are you going to set up, right? So this process in our lab is actually the procedure step. So when you fill in each of these steps, I want you to really think about your hypothesis and think about yourself on how you're going to begin this lab, right? Whether you're filling out your data sheet or you're setting up your ramp, you're measuring the materials you're using. Just every little step-by-step of how you're going to do this. Because remember, we are scientists in the classroom, and that's what we're trying to build. Okay, so in this lab, this specific one, in the beginning, we did the paper frog where we measured the distance with 3 trials and averages. The coin drop lab, we actually drew photos on how our setup looked, right? But this time, this specific one, we are going to use both. So I'm just going to read this. In this part of the lab, students are required to submit 2 types of data. The first being an image, drawing and labeled, or photo of their lab, if you want to take a screenshot or a photo of it. The second part of the data being collected must be the measurements of distance the cup/ball moves. And keep in mind, we are going to also find the average, right? And if you don't know how to find the average, please ask me for help, and I will. Also, something new, I also want to know the height of the ramp, right? Because when we set up the ramp, I want to know how tall it is. Can we measure it? Is it measurable? All right. And if you need help, right here, I put a star on the ramp height, which I will explain more. You know what? I'll just really quickly read it. Ramp height is the distance from the bottom of your books to the top of the ramp. All right. And finally, before we hand anything in, I always want to know the result. What is your conclusion? Was your hypothesis correct? Was it accepted or rejected? Right? Guys, I know you can do this, and I know you guys are going to try your best. Keep in mind, you always got to write in complete sentences, and if you need help, Mr. Escobedo is always here to help you. All right? Good luck, good luck, good luck, and please let me know if I can help.